Hi folks, and thanks for tuning in to this video about importing data. So what we're going to cover I'll be specific on first because I don't want you wasting your time here if you're looking for something else. There are a couple of different approaches to importing data. So one typically follows planning use cases where you really want a very prescribed contribution experience, involves building a cube to make it look exactly how you want contributors to be contributing to that cube, and then loading supporting actuals or other data for those contributors. So that's one use case. The other is very often follows analysis, where I have my data, I want to analyze the data that's in this file or this data warehouse or what have you, where really all you're trying to do is build a cube from that source that best represents the structures in that source. So that analytic use case is the one I'm going to follow here in this video. And we've got another one that you can click on here if you're more interested in loading data to a cube you've already built, which is a little bit different sometimes. So we'll follow this. We're going to be fairly source agnostic. We're just going to work with text files. The reason for that is that, like most ETL processes, there's three big parts. You've got a source mapping, you've got a transformation, and then you've got your target intent, what's going to happen in that target area. Now, the source mapping really, once you've done that for any source, is pretty agnostic. It doesn't matter. It's the work that happens after that we're most interested in. So this one's just going to focus on text files. If you're interested in specific cases of how do I do a package import from Cognos 10 or anything like that, we can show you that. There's lots of content to help you there. But this one's just going to be focused on an overview of importing and creating a cube from those data structures. So let's get started and have some fun. So I'm going to do this in Cognos Insight, but once again, this is the same import that we would be using in Performance Modeler, so nothing to worry about there. You can choose either tool. Again, we're going to do a file-based import, but just so you're aware, we can also do anything that's got an ODBC driver, ODBC compliant, relational data source. If we need to use SQL, we could also pull directly from a Cognos 10 list report or from a package. If there's other data there, we can also open an SAV file from SPSS statistics as well. So in this first page, a couple of things that I want to do. The first thing is to rename my import something that I'll remember. So I'll give it a name here. I'll locate the file. In this case, it's a CSV file. And one of the things you'll find does speed the import along is the fact that we automatically detect the type of file. Now, we don't just use the file name for that. In fact, regardless of what it's called, if we were to interrogate the first 100 lines and find comma delimited fields, then that's what we'd use and specify here. The other thing we do is compare the first row of data with the second and that sort of thing, so that we can easily identify here that the data has column labels. Those will be very useful when it comes to mapping our data, because those will automatically populate our level names, dimension names, and that sort of thing. One thing people often ask about is the final option here, which is to specify a location accessible from the Cognos TM1 server. Well, all that is a way that if I'm connected to a central server and I want to run automation on that process where I may not have a client open accessing the data, a way for that centralized server to reach the data. So very often this is going to be a UNC file share or something like that for automation purposes. We don't need to worry about that in this case, so we can move along, and all of our source details have been specified here. The next thing that I might want to do is modify what I'm going to import. So for example, enabling and disabling some of my columns of data. If some of these I wanted to treat as dimensions rather than measures, that will often happen when you've got integers representing IDs and things like that. If we've not spotted that those are in fact dimensions, you may want to turn that measure column off there by ticking the box. Otherwise, just a quick way for me to scan through, see what I want and don't want to include in this file, and move on. So this, the second step, will be where we spend most of our time and do most of our work. This is really the transformational portion of things where we take whatever our data looks like in a source, in this case a flat file, and turn that into dimensions, attributes, and a cube. Now, the first view you'll get of it here is really of our best guess mapping of that data. So we use a host of heuristics to try to analyze and understand the source. And from that, you'll see a number of things. So one of the things that we've evaluated here is from this item name column. Because we also have this item, we assume, correctly so, that this is an ID name pair. So we see this in a lot of data where you've got an underlying ID for an element, and you also have a caption for that you use for presentation. We'll put those two things together, so you'll see here that we have item name as our caption attribute for our items. This preserves the integrity of the relationship between those two, but for most things we hide that item and display the caption, so we only use the actual underlying item name when we need to. Similarly, we've spotted a relationship between brand and item, and we've constructed a hierarchy from that. So based on how we've sampled that data, we believe that this column represents parents of this column. Further along, we've also spotted a relationship between state and outlet, and of course identifying that some of those outlets have city names, that those then roll up to state, and we've constructed a hierarchy from that as well. Now, although we've done that up front for you, there's nothing to prevent you changing that, so you can determine exactly how you want this data to be treated, either by clearing all mappings or recreating those and choosing not to detect hierarchies. We'll also do that. We've also identified what we believe to be measures in this data, and what we call measures here are of course continuously variable values that are going to represent cell data in the cube. Now, those don't have to be numeric. We could in fact have text measures, there's nothing wrong with that, but our first guess on any text value will be that represents a dimension, an attribute, or a level. Now, to see exactly how these are going to be treated, you'll almost always be looking at the property. Properties exist for every single item that we import. So whether that's a cube, a dimension, a level of that dimension, any of the attributes or measures that we have in this import as well. The most important two that you're going to want to understand how to treat are cubes and dimensions. We can see here from the properties at the cube level that we're going to create a cube called national, and we're going to use a number of options to import that data, and these are really important. So the first one that I'll talk about is the data update behavior. There are two options. One is to add the data, the other is to replace the data. Now, the only time I would ever choose to replace the data is when I know for certain that the grain of the data I'm importing at is unique, so that each cell of a cube is identified and you're not going to have multiple values for a single cell where we would typically add those together. And there are in fact very few cases where I'll do that, because the nature of that import, again, if values are encountered that are duplicates, is that the last one wins. And in most cases of moving data, when the last one wins, no one actually wins. People will often choose that option though, when in fact what they want to do is clear out the data because they're doing a new import. And for that case, I would suggest to tick the box to clear the cube data instead, as that will do effectively the same thing. We'll be starting again from zero, but any transactions that need to be aggregated during the import, that will happen automatically. The option to retain zero values allows you to import zeros, which are different than nulls. For example, if I had a product selling at a particular store, but I didn't sell any of those, I might want to import zero, because that is, again, different than null, which might mean that I don't sell that product at that store, and that sort of thing. Replacing empty strings with default values is a great way to handle data that's coming in that's potentially missing things. If you're loading survey data, it's sometimes some of the messiest data you'll deal with where people haven't filled out a particular field or anything like that. Assigning a default value to that will allow you to see how many of those are empty and avoid rejecting the records as a result. Now, we're starting from scratch, so we don't have to worry about any existing dimensions that we might want to add to this import and perhaps filter, but we'll take a look at that when we look at updating an existing cube. So now let's take a look at a dimension. So the first one we'll look at here is our date field. What's interesting about our date field is that we've predetermined that this is in fact a time dimension because we recognize the date formatting in that column. Because of that, we can actually do a number of other things. So one that's been set for us is it will populate a whole year of data even if we don't have every day in this import. That gives us some more flexibility when it comes time to create expression logic on that date dimension. So for example, rolling up a last period balance like cash or something like that, head count, we can create those expressions very easily when we have a whole year to work from. But if you're just doing some very basic analysis, you can turn that off and we'll only import those days that we see values for. A few of the other items you see here are not specific to time dimensions. So for example, the update behavior, which right now, again, we're working with a new cube, so it doesn't matter so much. But right now, the option is to add new elements. So if I have existing ones in a dimension and I leave that option on, new ones will simply be appended. If we choose to repopulate that dimension, any elements that I have now but are not in this import source will be removed as the dimension will be completely repopulated. And the last option, again, one that'll be most popular when we're using import into an existing cube, is to not update the dimension at all. If an element doesn't exist in the dimension, just reject the record. But of course, as this is a new dimension, we don't have to worry about that. The other important properties that you'll see here are whether or not we choose to create a total element. That will always happen for you by default so that it speeds your analysis and you don't have to bother creating totals. But if you wanted to turn that off, you certainly could here. Similarly named levels. In the case of one of our dimensions down here, or a couple of our dimensions, we have both brand and item levels. But very often, and certainly if you're doing an unbalanced data source, you'll not want to see any named levels. You'll leave the traditional level numbering on and ignore the named levels. So we can do that as well there. And the last thing I'll talk about is the element and component sorting, which I like to specify as hierarchical for the element sorting in most cases, and do the component sorting, so the parent level sorting, by name. But again, you can sort these any way that you like, and that's how we can deal with the properties of a dimension. Now for measures, there isn't much that you'll typically want to do. You may or may not want to disable our generate count measure, which will help you a lot with any categorical data analysis when you're looking at lots of different products, and it's very handy to have a count available. But if you want to disable that, you can do so here. You can always delete it, but keep in mind with anything that you choose to turn on in the import and then delete later, like maybe a total, if you've left totals on and you say, well, I'll delete those later. Every time you re-import from this same process, if you don't change that, that's going to be recreated. So I'll get my count back or I get my total back. And the last thing I'll take a look at here is a level that we've created. And you'll see a couple of things here that do matter. So exactly how it's mapped. You can map anything you like by just dragging it from the left to the right. So for example, if I wanted to create a hierarchy here, and I might just do that, where my product line is in fact the parent of my brand, I can do that very easily here just by dragging that in. But if you find that the drag and drop gets finicky between where an attribute drop zone is, or a dimension, or a level, or anything like that, you can always just, and I'll just clear this guy by right-clicking, you can always just specify over here in the properties that this is a level, and then say which dimension is the owner, and then what is the index of that. So in this case, the owner dimension is going to be the item name, and the level index is going to be 1. So that's going to be the first one here at the very top of the hierarchy. So with all of that in place, I can now click on the Summary tab to see exactly what's going to be happening in the target when this data is transformed and delivered. So first off, I'm going to get a new cube called National, and then several new dimensions for date, item name, outlet, market, and also we're going to take that date dimension, specify a fiscal start of January, which I could have chosen, and I'm going to specify that the whole year will be populated, not just values that happen to exist in my data source. So we're going to create a full year dimension, but it could be that many of the days within that year are missing values. So now let's click Finish and see what we get for a cube. And in the first view, you see exactly what I was talking about with our populating the whole years. So I have a date for January 1st and so on, even though I don't actually have values for any of those. Now from an analytics standpoint, that could be ugly, but very easy to clean up. We'll just zero suppress those out. And now we see data just for those dates that actually had sales. You'll notice that when we created that time dimension, and again we allowed the calendar start to be January, but we built a larger hierarchy from that. So rather than just having individual dates, I could actually expand this to months or quarters or at the full year level. So I actually have 2 years of data here that I can look at. Our item name, you'll remember we built a substantial hierarchy from as well, and we can expand that to the product line, the brand, or the item. So if I expand to my individual items, I can see there that because there wasn't uniqueness, so we have some brands that sell within various types of items, so that dishwashers, we have an Acme brand, but we also have stoves as an Acme brand. The import process created uniqueness for us, and that was one of the options that was there as well. We didn't talk about that one, but creating captions that append the parent name to the child name to get the uniqueness that we need in the dimension. We'll also look at here what happened with our item name. So we can see we have an item here called the Acme Wash. You'll recall from our import that we recognized item name as the caption. Now let's take a look at the invariant name under that. So if we look here, we'll see the actual ID, D83020, is the underlying invariant name or system name for that ID that we imported. But also appended to that is the hierarchy so that we can get the uniqueness. So that value as it appears under Acme and dishwashers, again because we don't have the uniqueness that we need directly from that import. It was created simply by concatenating the names of our brand, line, and the item ID. And the last thing I'll show you before we conclude is a very common mistake I see, and we talked about it a little bit in the beginning here, of how we update data. So we'll spend a lot of time on that in another video, but very quickly want to show you the number one mistake I see people do when it comes to updating their data is that they have this add the data turned on by default, of course, and we talked about that's in most cases what you want to do, but they've left the default of clear the cube data turned off, and we want to turn that on, because if I rerun this import with it off, and we'll take a very quick look at that here, you're going to see that my data will in fact double. And that is, of course, because we're incrementing up the values that are already there. So now every time I execute this process, that's just going to keep doubling up. So hopefully that overview helps you get productive with loading data into TM1, whether it's Cognos Insight or Performance Modeler that you're using to do that. If it doesn't, if you find that you get stuck anywhere, please do check out a number of other videos that focus on some of the more detailed aspects of it and solving specific challenges you might have with your source. And don't forget to try this out yourself with some of the great exercises that we have available. Thanks for your time.